In this video, we'll be running a paired t-test in RStudio. We're again going to be using our example dataset, which I brought into our environment and renamed example. This dataset contains a sample of adults who participated in a study where their heart rate was measured before a treatment was applied as well as after. So we have the resting heart rate measurement of every participant in beats per minute, as well as after the treatment was applied in beats per minute. We want to run a paired t-test to see if there was a mean difference or a mean change in heart rate from before to after the treatment. First, let's create a vector that contains all of the heart rate differences for every participant. We'll call it heart rate underscore diff. And that's just going to be equal to our heart rate after the treatment minus our resting heart rate. To visualize these differences, we can use the hist function and just give it our vector. We can see that the differences in heart rate are approximately normally distributed, and therefore we meet the normality assumption of a paired t-test. We can calculate the sample mean difference of these heart rates by just using the mean function on our vector. And we can see that the mean difference in heart rate from before to after the treatment was applied is almost 11 beats per minute. To test if this is significantly different from zero, in other words, was there a significant change in the mean heart rate of these participants after the treatment was applied, we'll use our paired t-test. Similar to the one sample t-test, we're using the same function, t.test. However, the arguments we give this function will be slightly different. We're going to give our after heart rate measurement as the first argument, then a comma, then our second heart rate measurement, our resting heart rate, and then we need to tell R that this t.test function is getting two paired measurements, so it'll run the correct t-test. So we'll tell it paired equals true, and make sure that true is in all caps. It will turn blue if you do that correctly. When we run this function, we'll be able to see the results of our paired t-test. The test statistic, 9.53, our degrees of freedom, the number of subjects minus 1, and our p-value, which here is in scientific notation because it is so small. So we have 0.00013 zeros, 6784, which is essentially a p-value close to 0. Since that will be less than our alpha, we're going to reject the null hypothesis and say that there is a significant difference in our mean heart rates from before to after the treatment. We can see our sample mean difference here at the very bottom of the output, 10.89, what we just calculated. And we also have a 95% confidence interval for the mean difference in heart rate